Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the simple problem called group anagrams. Its index is 49 and it is a medium type problem of the LeetCode, but I don't think this should be a medium type. This is really an easy problem. Okay, so without wasting our time, let's discuss this. Given an array of strings, you can see over here, and we have to group the anagrams together. That is, if two strings are anagrams with respect to each other, then we are going to group these two strings into a single group. Like we are going to keep both of the strings in a single group, right? And we are going to return the answer in any order. Like we are going to return the which elements, which strings are in which group. Like we are going to return the vector of strings, where the every element of the vector is going to represent a particular group, where the every strings are anagrams with respect to another string. Okay, now the concept of anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So let me explain this in a simpler word. It's like if let's say string s1 is the anagram with respect to s2, like s2 is also anagram with respect to s1. Then what is actually being defined over here is like if you find out the frequency of string s1, then the frequency of every character in s1 must be matching with frequency of every character in s2. Okay, so let me take another example and explain you. So what I'm going to do is like let me go over this one. Like suppose we have a string like abca, and we have another string called cbaa. So if you find out the frequency of every characters of this one, like a is coming out two times, b is coming out one time, and c is also coming out as one time. If you find over here, a is also coming out as two times, b is also coming out as one time, and c is also coming out as one time. So if you just check it out that if a particular character is existing in this string s1, then it must also exist in s2, and and this frequency must match. If it is not matching, these strings are not anagrams with respect to each other. Okay, so let me introduce another character d over here. So the frequency of d over here is 0, which means that the character d is not existing in the string s1, but d is going to exist in this one, and its frequency is 1. So these strings now s1 and s2 are not anagrams of each other, because there exists a character which is existing in s2 but not existing in s1. Note that, like suppose let's recall the string s1 as abc a and s2 as abc. Okay, so if you find out the frequency of every character in s1, you can see a is coming out as two times, b is coming out as one time, c is coming out as one time, and in this case also a is also coming out as one time, b is coming out as one time, and c is coming out as one time. You can see that the all the distinct characters are which are present in s1 is also present in s2, but the frequency of a is not matching. You can see in the s1 frequency of a is 2, and in the s2 frequency of a is 1, which is not equal. In this case, s1 and s2 are not anagrams of each other. Overall, you have to check it out that every string which is present in s1 must be present in s2, and their frequencies also match. Then we can say they are anagrams with respect to each other. Okay, so we would be given of strings, and we need to group these strings into the, like a particular group is going to represent a, like all the pair of strings are anagrams with respect to each other, and we have to return all the groups. Okay, and let's hover over to the constraints. Like you can see the strings length, like array of strings which would be given to us is around 10 power 4. So what we are trying to do over here is like we are trying to have a O of n squared, like n squared is not going to pass. So we would try to keep this like let n be the str's length. Then we would try to keep n as it is, like the time complexity. It would be right O of n into m, where m is the length of a particular. You can say that m is the length of each string. In worst case, you can see every string length can go up to 100. So you have to be like time complexities go around O of n into m, but here we are using the solution based on the time complexity O of nm log of m, because we are sorting the strings. Okay, I will tell all that concept later on. For now, let's understand how we are going to do that. So let's move further. Okay, so let's take an example from here itself. Like, okay, so let me do this one. Okay, so what is being given over here is like we have the strings like eat, we have the string like tea, and we have strings like tan, we have strings like 8, and we have string like nat, and finally bat. Now let us pick up the anagrams. Like you can see that what is being included in our answer is like this is one group, and the another group is like let me name it as here at 1, and the another group is like 2 and 2, and another group is like 3 3 3. If you look over this one like eat, tea, and 8, okay, you not including this one, you can see that these strings are anagrams with respect to each other. If you include eat and 8, how we are going to check that efficiently? We are going to check that efficiently by sorting this one, sorting the strings. You can see that if I will sort it out, it would becomes a, e, and t. Again, if I will sort this string, it also becomes aet, and both are equal. We are going to check that efficiently with the help of this sorting technique. If the in the worst case, what is the maximum length of this one string is like m is exactly equal to 100. So worst case sorting time would be like m log of m. So this is the sorting time. Okay, now the thing is like how we are going to group that efficiently. So the thing is like we are going to use unordered map first, because insertion and deletion is going to take O of one time. Unordered map where the first key would be like a string, because we want that every distinct anagram, like according to the previous example, you can see that if I will sort it out eat 8 and what is that t, then all becomes aet, right? So this is one of the distinct string, and all those strings which on sorting is going to yield this string will be grouped into one single group. And if you sort this tan and nat, you are going to get ant, like ant. And all those strings which on sorting which is going to give this string is going to be grouped into a single group. Okay, this is the concept that I am going to use. That's why I've used unordered map to keep the distinct strings, and also to group the strings I am going to make it as vector of string. Okay, so this will be our unordered map, and what I'm going to do is iterate for every of the like iterate every strings, like iterate over EAT, iterate over TEA, and all those strings, and first sort it out. So sorting would take O of m log of m time, and then we are going to insert that sorted string into our unordered map. And on inserting, note that we must have to be careful that we are going to insert on that particular group which is like eat, and you can see that with the help of example, eat and 8 should be kept on like same group. And how we are going to check that? We need to sort it out first, aet I think, and aet. So what I'm going to do is, so I will say let unordered map will be mp, then I will say yes, mp of aet will contain following strings: EAT, 8, and finally the last one TEA. Similarly, all the other strings would be kept like this one. Okay, so let's look over the code how this could be easily implemented. So you can see that this is basically our unordered map, and iterate over every strings and store the current string, then sort it out and insert into the map. Note that this entire operation is going to take O of nm log of m, where n is the str's length and m is the length of a string. Okay, and finally after doing this, we have for every entry in our unordered map, we have some particular vector representing the group of like current group elements, and which is our grouped anagrams, and we need to store into our answer finally. So answer will be of this type, vector of strings. So iterate in the unordered map and store that value, that is I dot second, which is the vector representing all those strings in a same group, and finally return the answer. This will give you all test cases passed. Okay, So if you have any doubts, do let me know in the comment section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.